Hello, welcome again. We are solving some questions of theory of machine. The topic is can, governor, and gyroscope. Question number 29 is a disc with radius of gyration of 60 mm and a mass of 4 kg is mounted centrally on a horizontal axle of 80 mm length between bearings shown in the figure. It spins about the axle at 800 rpm counterclockwise when viewed from right hand side bearing. The axle processes about a vertical axis at 50 rpm in the clockwise direction when viewed from above. So this is your counterclockwise, this is your clockwise when viewed from above and when viewed from right side. The resultant reaction on bearing A and B, option A 59.4 Newton, 98.6 Newton, option B 86.1 Newton, 61.5 Newton, option C 98.6 Newton, 59.4 Newton, option D 61.5 Newton, 86.1 Newton. So here the mass of the bearing, mass of the disc is given as 4 kg and radius of gyration is given as 60 mm, or it is here or 0.6 meter, and length of the bearing is given as 80 mm or 0.08 meter, and omega is your 2 pi n by 60 because rpm of the disc is 1800 rpm and rpm of precession is your 50 rpm. So omega is your omega comes out as 83.78 and omega p comes out as 5.24 radian per second, because as both velocity of spin and velocity of precision are involved, so there should be a gyroscopic couple which amounts to I omega omega p. So I is your 0.0144 mk square and omega is your 83.78 and omega p is your 5.24. So gyroscopic couple will be here 6.32 Newton meter. So now this is the amount of gyroscopic couple. Now we have to determine the direction of the gyroscopic couple to find out the reaction on the bearing. So this is your disc, and if we draw as it is rotating in counterclockwise direction, so if we draw its spin vector, then it will be in rightward direction because this is anti-clockwise, and if we will from this side, then it will be, then this OA is your spin vector. Okay, and now velocity of precision is in clockwise direction. Okay, as it is in clockwise, so the vector the spin vector will shift to OB. Okay, so this is the direction of active couple, and this is the direction of reactive couple. So reactive couple will be if it is as it is going away from us, so it will be your clockwise direction. So the reactive gyroscopic couple on the shaft will act in clockwise direction. So this is your shaft. Okay, so the reactive gyroscopic couple on the shaft will act in clockwise direction. So it will try to bring this end down and bring this end up. Okay, so when it is trying to bring this end down, so there will be reaction on bearing. It will touch the bearing, and bearing will provide corresponding reaction. So due to gyroscopic couple, the reaction on the right hand side of the bearing, on the right hand side bearing, will be the upward direction, because this is your clockwise and this will act on this shaft, and the corresponding reaction provided by the bearing will be in upward direction because it will try to bring it in downward direction. So reaction on the bearing will be in upward direction. Similarly, it will try to bring this end in upward direction because of clockwise sense of gyroscopic couple. So the reaction on the bearing will be in downward direction. So this is the reaction provided by bearing due to gyroscopic couple. Okay, and as the length of the shaft is given as length of the shaft between the bearing is given as 80 mm. 80 mm. So the and gyroscopic couple is just 6.32. So the value, the magnitude of this reaction will be 6.32 divided by 0.08, that is 79 Newton. So at end A, it will be in downward direction for bearing. Okay, for shaft, it will be in upward direction. For bearing, it will be, because reaction is provided by bearing, so bearing is for bearing it on the bearing, the reaction will be in downward direction, and similarly that amount will also be same, but it will be in upward direction. Okay, so that Rg is due to gyroscopic couple, and Rw is due to static load on the shaft. So that static load on the shaft is your disc load, and this weight disc mass is 4 kg. So due to this weight, the reaction on the both sides should be equal, and it will be equal to 4 into 9.81 by 2, that is 19.6 Newton. And so now the reaction due to gyroscopic couple on the left hand bearing is your Rg, and due to static load it is Rw. So the net reaction on the bearing A is your Rg in downward direction minus Rw in upward direction. Okay, because they are the opposite, so we'll subtract them. So 79 minus 19.6, or that will be 59.4, because Rg is in downward direction. Similarly, the reaction on the on the right hand bearing, or on the bearing B, will be your Rg plus Rw, because both are in same direction. Okay, so that is 79.19.6 or 98.6 Newton upward. So it means we have due to gyroscopic couple, we have found out that the gyroscopic couple is acting in clockwise direction. So that gyroscopic couple will act on the shaft. Okay, so it will try to bring that part down and that part up. So when it will touch the bearing, okay, so the reaction will be provided by bearing, that will be in upward direction. Okay, and then this will touch the bearing, so the reaction will be provided, that will be in downward. And due to weight, the reaction will be same, that is in upward direction. Okay, so answer should be your 59.4 downward on bearing A, and 98.6 upward on bearing B. So I am reading out for you. So we have determined the gyroscopic couple. So the applied active and reaction couple are shown in the figure. The reaction couple is clockwise when viewed from the front, and tend to raise the bearing A, and lower the bearing B. Okay, thus the reaction of the each bearing is in turn downward at A and upward at B. So these are the reactions, and these are the static reactions. So we can find out these answers. Okay, and the reaction at the bearing A due to gyroscopic couple is C by L, that is 79 downward, and at the bearing B is your due to gyroscopic couple Rg 79. Okay, that is in upward direction, that is in downward, that will be in upward direction, and reaction at the bearing due to weight of the disc will be weight by 2, that is 2. So net reaction on bearing A Rg minus Rw, and net reaction at bearing B Rg plus Rw. Okay, so answer is option